Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is continuation part 3 of previous problem when two billiards balls hit each other, one at rest, another approaches with constant speed. He hits this second ball and it's not head-on collision and they fly at different angles. And we proved in two ways in two previous problems, and links in the description, and please don't forget link to the whole playlist. We have proven that they fly after the collision at 90 degrees. No matter what. They will fly, one will go here, another will go here, and they will fly at 90 degrees. And in this problem they want us to find the final speeds, and they give us initial speed of the first ball 10 meters per second, and they also tell that this angle is 30 degrees. So they want to find V1 and V2. So how you will do it? Of course, if this is 90 degrees, then this is 30, then this beta, and you right away say that beta equals 60 degrees. Wonderful. And also you can draw a projection, or you can draw a triangle. And this would be triangle with alpha equals 30, and this would be V, and this would be V1, and this would be V2. Like we did in the previous problem. And then V is known, alpha is known, so it's very easy to find V1. V1 equals V cosine alpha. V1 equals V cosine 30 degrees. Right? And V1 equals 10 cosine 30 degrees is square root of 3 divided over 2. V1 equals 5, because 10 over 2 is 5, multiplied by 1/7 meter per second. 5 multiplied by 1.7, very roughly 8.5 meter per second. So this ball will carry this speed. Fantastic. What about this? Well, this is again triangular, this is opposite side, so we can say that V2 equals V sine alpha. V2 equals V sine 30 degrees. V2 equals V multiplied by 1/2, right? And V2 equal 10 and half would be 5 meters per second. And basically that's almost it, because we answered the questions, we found V1 and we found V2, but let's prove that the energy is the same. The law of conservation of energy in this case, like in any other, would be any other elastic collision would be this. Kinetic energy, I just validating that everything is fine because just want to be sure. M cancelled out, 2 cancelled out, V squared equal V1 squared plus V2 squared. Let's plug the numbers. Instead of V we plug 10, so we will have 100. Instead of V1 we plug 8.5 squared, some round number, plus 5 squared, right? And then roughly 8 squared is 64, 8.5 would be 75. If not, you can validate it on your calculator, and if I'm wrong, because it would be not 75 but something, then it's not exactly 8.52, so you can validate this plus 25, and we have 100 equals 75 plus 25, everything fine, as it should be. We only validated that ourselves, that we didn't make any stupid mistakes. And that's it about this collision, not head-on, but completely elastic. And probably next problem would be not about collision, not about when something comes combined, but something is just like blows up in different directions. And it's also another area where the law of conservation of momentum is extremely helpful. Like, subscribe, bell, put your question, put your comment, ask a problem. I see you next time. Thank you very much.